100 million. I mean, just think about that number for a second. That is exactly how many users ChatGPT gained in just 2 short months after it launched. To put that staggering figure into perspective, it's literally the fastest-growing consumer application in the history of the world. The explosive pace of AI adoption right now is completely unprecedented. It is changing our reality way faster than most of us can even process.
Welcome to The Explainer. Okay, let's dive right into this, because today our goal is to strip away all those Hollywood sci-fi myths and take a really close look at the actual engine driving the modern world. We are demystifying artificial intelligence, so we can see how it truly works, far beyond the hype and the flashy headlines.
Here's a quick look at our agenda for today. First, we'll be defining artificial intelligence. 2, how machines actually learn. 3, AI in the real world. 4, ethics, bias, and risks. And finally, 5, the future of humanity.
All right, Section 1. Defining artificial intelligence, separating fact from fiction. Before we can look at the future, we have to ground ourselves in what these terms actually mean right now.
So artificial intelligence, or AI, is basically just the capability of a computational system to perform tasks that we typically associate with human intelligence. We're talking about things like learning, reasoning, and problem-solving to achieve defined goals. And I really want to emphasize that last part. It's not magic, it's certainly not a conscious being, it's fundamentally a mathematical system performing human-like tasks to reach a very specific, programmed goal.
Now, sitting right under that broad AI umbrella is machine learning. Think of it like this. Instead of a human programmer sitting down and writing explicit, step-by-step instructions for every possible scenario, which is impossible, this method allows programs to improve their performance on a task automatically. How? Simply by finding patterns in data. The machine organically learns the rules by digesting massive amounts of information.
And if we go one level deeper, we hit deep learning. This is where things get really fascinating. This uses artificial neural networks with multiple layers which loosely mimic the connected neurons in your own brain. These multiple layers work together to progressively extract higher-level features from data. It's exactly how your smartphone can instantly recognize your face or translate a foreign language in real time.
But this technology didn't just pop up overnight. Alan Turing introduced his famous test way back in 1950, and the field was officially founded at a Dartmouth workshop in 1956. For decades after that, the field actually went through wild cycles of extreme optimism, followed by huge disappointments and lost funding. Researchers called these the AI winters. But look at 2012. That's when we saw an absolutely massive deep learning breakthrough. It was driven by faster graphics processing units, GPUs, and a sudden explosion of massive datasets. That one breakthrough completely paved the way for the generative AI boom of the 2020s that we're all living through today.
Moving right along to Section 2. How machines actually learn under the hood. Let's open up the black box.
So how do we actually teach these models? There are 3 primary ways. Step 1 is supervised learning. This is where we feed the machine training data that's already labeled with the expected answers, like showing it thousands of pictures explicitly labeled cat. Step 2 is unsupervised learning. Here, the AI analyzes a stream of raw, completely unlabeled data and just finds hidden structures or patterns entirely on its own. And step 3 is reinforcement learning. Honestly, think of it like training a very stubborn digital puppy. The system is literally rewarded for good responses and punished for bad ones. It is just incredible how applying these basic systems of rewards and pattern recognition to massive data allows a machine to learn.
All right, Section 3, AI in the real world, from theory to reality. Let's look at what this actually looks like in practice.
The diverse real-world triumphs of this tech are just staggering. In biology, an AI called AlphaFold successfully predicted the 3D structures of proteins in hours. That is a biological mystery that literally used to take human scientists months or even years to solve. We've got AI agents mastering incredibly complex video games, flat out beating professional human drivers in Gran Turismo using that reinforcement learning we just talked about. In medicine, AI-guided drug discovery has identified entirely new classes of antibiotics to fight drug-resistant bacteria. And of course, generative AI tools like ChatGPT and Midjourney are instantly creating original text, software code, and stunning images from simple text prompts. The impact across literally every industry is nothing short of revolutionary.
But we do have to flip the coin. Section 4, ethics, bias, and risks, the dark side.
This brings us to a really critical question. What happens when the algorithm is wrong? See, we as a society often have this assumption that computers are perfectly objective and mathematically fair, but they learn from human data, and human history and human data is deeply, deeply flawed.
Let's consider the real-world impact of algorithmic bias. Back in 2016, an investigation by ProPublica took a hard look at Compass. That's a commercial AI program widely used by U.S. courts to predict the likelihood of a defendant reoffending. And the findings were pretty stark. The system consistently overestimated the chance that black defendants would reoffend, while simultaneously underestimating the chance for white defendants. The absolutely crucial takeaway here is that if an AI is trained on biased historical data, it doesn't magically fix the bias, right? It just automates and predicts biased outcomes for the future.
Then there's the massive physical cost of all this intelligence. 10 times. Every single time you run a ChatGPT search, it uses up to 10 times more electrical energy than a standard Google search. The environmental footprint of training and running these massive AI models is astronomical, and it is putting an unprecedented strain on our power grids everywhere.
To put that sheer power hunger into perspective, the consulting firm McKinsey estimates that by 2030, a mind-boggling $2.7 trillion will be invested into AI infrastructure and data centers in the U.S. alone. I mean, we are literally seeing major tech companies negotiating to reopen decommissioned nuclear power plants like 3 Mile Island just to feed the electrical grids required for these data centers. The physical scale of AI's power demand is just immense.
And right alongside that physical impact is a huge societal one, the threat of misinformation. AI recommender systems on platforms like YouTube and Facebook are designed with basically one goal: maximize your engagement. They figured out pretty quickly that extreme partisan content keeps you watching, which traps users in these polarized filter bubbles. Now, combine that dynamic with generative AI's ability to create highly realistic deepfake videos, images, and audio. It creates a landscape where bad actors can easily weaponize AI for large-scale computational propaganda. It makes manipulating public perception with fake media that is completely indistinguishable from reality terrifyingly easy.
Which leads us to our final section, Section 5, the future of humanity, the existential horizon. At the absolute core of this existential horizon is what researchers call the alignment problem. The question is, how do we ensure a superintelligent machine is fundamentally aligned with humanity's morality and values before it achieves a point of unstoppable self-improvement? Because here's the thing, an AI doesn't need a Terminator-style robot body to be dangerous. As the historian Yuval Noah Harari points out, human civilization, our laws, our economy, our ideologies, it's all built entirely on language. If a superintelligent AI can master language and persuasion, but its goals aren't perfectly aligned with human survival, the results could be catastrophic.
And look, this isn't just some sci-fi movie plot. The brilliant physicist Stephen Hawking famously warned that the development of full artificial intelligence could, quote, spell the end of the human race. Even the AI pioneers, the very people who actually built this technology, like Geoffrey Hinton, who recently left Google just so he could speak freely about these risks, they have expressed severe concerns about humanity irreversibly losing control of the very intelligence we're creating.
Which leaves us with this final lingering thought. Is humanity prepared to align superintelligence with our own survival? This technology is advancing at an exponential, breathtaking pace. But our safety frameworks and our ethical guardrails? They're only just beginning. Keep questioning the algorithms, keep learning, and absolutely keep your eyes wide open to the incredible future of this technology. Thanks for joining me on this explainer.